Okay, so now we're going to get into probably the most important topic in Algebra 1. This is factoring is in every math class you're going to see from here on out, and it's just assumed that you know how to do it. The first thing I want to do is just lay some ground lines, okay? I feel like sometimes when kids are doing these, they're overwhelmed with what to do because they look so different sometimes, and it's just like you don't know what to do in each situation. So in this case, what I always like to do is when we have two terms, okay, you can easily count the number of terms by looking at the problem and seeing how many terms there are. The first thing you're always going to try when there are two terms is what we call difference of two squares or dots. And I'll show you an example of that, and I'll explain what I mean. If you can't do dots, then that automatically means it's just a simple greatest common factor problem, a GCF. When you get to three terms, there's only one thing you're going to do. For three terms, you're going to check for the GCF, then do MAG. The reason we want to check for the GCF first is because we want that leading coefficient to be 1. We want it to be 1x squared because then we can do the trick when we're factoring as opposed to splitting the middle, as I call it. And then when we have four terms, the only thing you can do is what we call factor by grouping. So when I'm teaching my classes how to factor for the first time, I feel like I just pound this into their heads. When there's two terms, there's only two things you can do. When there's three terms, you can only do MAG with a GCF. And when there's four terms, it's only factor by grouping. This seems to lighten the load a little bit and ease your mind as to freaking out about how many things you can do. So let's go ahead and look at number one here, keeping our things above in mind. I count two terms. There's 5y squared and 25. Okay, so I'm going to try to do difference of two squares. Well, right away, I see a plus sign. So I know I can't do difference of two squares because it's not a minus. So that tells me I'm going to try to do GCF. Well, the GCF of 5y squared and 25 equals 5. So I pull that out. If you forget how to use the GCF, whatever this number is right here is what you're going to divide each piece by to get what goes inside your parentheses. So 5y squared divided by 5, those cancel. I get y squared. 25 divided by 5 is 5. So our final answer is 5 parentheses y squared plus 5. Okay. Then I can go ahead to number 2. I count two terms again. All right. So that's good for difference of two squares. Now, this is when you should think, can I square root 18 and can I square root 24? In this case, both of those numbers, we can't square root and get a whole number. That means that we're going to not do difference of two squares. So it's GCF again. So now I like to always write GCF off to the right so we know what we're dividing by. So 18 and 24, the biggest number that goes into both 18 and 24 is going to be 6. Okay. When we're dealing with letters, variables, we always take the smaller ones. So x to the first, and then I have y to the third, y to the second, y to the second. So right now I know 6x, y to the second is going to go outside my parentheses. That means I'm going to divide each one of these by 6xy squared. That's going to tell me what's left inside my parentheses. So 18 divided by 6 is 3. X squared over x gives me x. Y to the third over y squared gives me y. Minus 24 over 6 is 4. The x's cancel. The y squareds cancel. Here's our final answer. Okay, so now let's get to some ones where we can actually do difference of two squares. So in this case, number 8, m squared minus 81. Both of those can be rooted. There's a minus sign between them. That's good for difference of two squares. In this case, I know there's always going to be two parentheses. The square root of m squared is m, so m's go here. The square root of 81 is 9, so the 9's go there. And then I always have to have a plus in one and a minus in the other. The reason you have to have a plus and a minus is so that the middle term cancels out. That's why difference of two squares works. We could do MAG with this and have the a be a 0, but that's much longer. Similarly in 9, there's a minus sign. Good. Two terms. Good. 25 I can root. 49 I can root. That's all good. So I know going to be 2 parentheses. If I square root 25x squared, I get 5x and 5x. If I square root 49, I get 7. So I put 7 and 7 there. First one plus, second one minus. Problem's done. Okay, so that deals with 2 terms. Now let's look at some that have 3 terms. Number 6. The way I always say it, as I always say, 1, 2, 3, MAG. I count 3 terms. I know we have to do M, A, G. To get M, I'm going to take the first number, multiply it by the last number. So 8 times 9 gives me 72. My A is always going to be the middle number, which is 17. So when you get to this point, what you're really thinking is, what numbers multiply to give me 72, but when I add them, I get 17? Well, that takes a little bit of time to think about in your calculator. There's some ways you can find that. Once you do get it, this is where you're going to write G. I know that 9 times 72, or 9 times 8 is 72. I know that 9 plus 8 is 17, so my G is going to be 9 and 8. Because of the fact that this number right here is not 1, we have to split the middle. So what that means is I take this middle term, 17x, and I split it to the 2 numbers we just found in G. So I'm going to write 9x plus 8x. Again, I got those from G. The rest of the problem remains unchanged, 8x squared and 9. These are the 2 bookends that don't change. Now, when we have 4 terms, which we'll get into a little bit later in more depth, we factor by grouping. Now I'm going to take the GCF out of the first parentheses, being an x. Gives me 8x plus 9. Out of the back parentheses, there's no big number I can take out, so whenever there's nothing, we're going to pull out a 1. 8x plus 9. At this step, I see that I have the same thing in parentheses. That means it's good. So that means that my first set of parentheses, I'm going to take those numbers, and I'm going to have x plus 1. Because that matches that one, my second parentheses is 8x plus 9. There's your answer. Again, we only split the middle because of the fact that we had a number that wasn't 1 in front of x squared. Well, here, number 7, you see we have that. That's a 1x squared. So I count 1, 2, 3 terms, so MAG. My M is going to be 1 times negative 60, which is negative 60. My A is negative 11. So the numbers that multiply to 60 and add to negative 11, we can find those by looking in your calculator, messing around that way, looking at your book. So right now I'm looking through my calculator to find out which ones they are. Okay, and I got that it's going to be negative 15 and positive 4. So my G is negative 15, negative 4. Here's the great thing when you have a 1 in front. When you have a 1 in front, this automatically groups to x minus 15, x plus 4, and your answer's done. You don't have to split the middle in that case. All right, next one. This is one, the first 2 problems we just did MAG didn't have a GCF, so I went right to the MAG. In this particular case, yeah, we could do MAG right away, do 2 times 16, 32, and get 12. But if you take out a 2 and get x squared plus 6x plus 8, this problem becomes significantly easier. Because I'm going to pretend that this 2 out front, I'm going to pretend that that's not there until the end of my problem. So when I do MAG, my M is 1 times 8, which is 8. My A is 6. The 2 numbers that multiply to 8 and add to 6 are 4 and 2. Well, you might be saying, well, why does this matter? Why is this beneficial to us? If we pretend that this 2 isn't here, okay, if we pretend that that's not there, well, this is now a problem that has a 1 as a lead coefficient in front of x squared. So I know I can say x plus 4, x plus 2. You see that the 2 that I magic marked out there came back. This 2, You can't forget about it. Goes right here, out in front. Our final answer is going to look like that. 2 parentheses x plus 4x plus 2. And finally here, we're just going to do a little practice with just a simple, I count 4 terms here. 10x to the third, negative 25x squared, 4x, and negative 10. Whenever you have 4, it's automatic factor by grouping. Okay. The GCF I'm going to take out of the front is a 5x squared. Okay. If I want to do this, I can still do this. Gives me 2x minus 5. Out of the back, I'm going to take out a 2. If I want to divide by 2, I can. It gives me a 2x minus 5. We're in business because these 2 parentheses match. So that means that this and that come down. That's my first parentheses. My second parentheses is obviously going to be 2x minus 5. There's our answer. So again, can't stress enough how important factoring is. I know it seems like a lot and it seems like it's overwhelming. If you go back up to the top and you follow these guidelines, 2 terms, dots or GCF. 3 terms, MAG. 4 terms, factor by grouping. It's not all that bad if you remember your rules.